In these problems, we will be writing single logarithms as a sum, difference, or multiple of logarithms. In other words, we're going to be expanding these already condensed logarithms. And again, we're going to use our properties. I'm going to write those down here so remember. The log of a product is going to be the sum of those logs. The log of a quotient is going to be the difference of those logs. And the log of a power, it's going to be the multiple of that log. So we need to kind of ask ourselves, do we have a product, a quotient, or a power here? And in this example, we actually have two things happening. We've got a product overall, and then there's a power on this y. We'll deal with that momentarily. So this product, we're going to say, is going to be the sum of these logs. So it's 100 times x times y to the fourth. So there are my three pieces for my sum using that first product rule. Now, this power is going to now become a multiplier on this log using that third property of logs. So we will say log of 100, but I'm going to think for a second about that. That's base 10. 10 to what power is 100? Let's say 2. We'll simplify as we go here. 2 plus the log of x plus 4, remember that was a power, and now it's a multiplier, 4 log of y. In this second example, I'm seeing a quotient. Just on my first instinct here, I see, whoa, it's a fraction. So this is going to be our second property here, the log of a quotient. So we'll make that into the log of a difference, the natural log of the square root of x squared plus 5 minus the natural log of x. Now, you might think you're done here, but this square root is actually a power. Remember what power that is? That's a 1/2 power. So you could rewrite that for yourself so that you can see, oh yeah, it is a power. And then we're going to utilize this power rule again. That power is going to become a multiplier. So we will say this is 1/2 the natural log of x squared plus 5 minus the natural log of x. And we are expanded at this point. Now, some people are tempted to change this x squared plus 5, but we don't have a property for the log of a sum. We only have product, quotient, and power. So this is done at this point. Last one here, this last piece could be considered a product or a quotient. We'll see why in just a moment. Initially, I'm going to see a product here. So I'm going to break this apart, expand it out into the log base 5 of 8 plus the log base 5 of x to the fourth. All of these components and these factors plus the log base 5 of y to the negative second. Now, this 8 is okay. I don't know the base of 5, what power would give us 8. We don't know that, so we're going to have to leave that as is. But then I'm noticing powers here. So we're going to utilize our power rule, which means those will become multipliers. So 4 log base 5 of x minus, when that's a negative, this is going to become minus log base 5 of y. And this is expanded. Now, if you notice here, we have a sum, but we also have a difference. So that means this must have been some sort of a quotient ultimately at the beginning in order for us to end with a minus sign. So I'm just going to think about that for a second up here. What does a negative power mean? Well, we have 8x to the fourth, but the y is to a negative power. So truly, that's over y squared. And that would make sense with our answer here, why we have a minus sign at the end. Either way, if you didn't know that, you would have a negative here because of the negative power. It becomes a minus as the multiplier. So if you knew that, great. If you didn't, it worked out just the same.